Chapter 4, the first section is about inverse functions. First thing we're going to talk about is one-to-one functions. In order to be a one-to-one function, you have to have for every x, there's corresponds to 1 and exactly 1 y, and then for every y corresponds to 1 and only 1 x. So it's kind of both sides of just normal functions. So to be a function, just a regular function, right? So if we list a number of x's, right, 1, 2, 3, and list, so that's our domain, right, our x's, and here's our range. And we're going to map our x's to our y's. So 4, 5, 6. So for every x, to be a function, for every x goes to 1y. So every x goes to 1y. That's a function. In order to be a one-to-one function, every y has to go to 1x. So this y came from this 1x. This 1y came from this 1x. This 1, 6 comes from 2. So this is a one-to-one function. You can write it like that, one-to-one function. Here's an example of a function, but not a one-to-one function. So 1, 2, 3, 4, 5, 6, 7. So this is not a one-to-one function. 1 goes to 5, 2 goes to 4, 3 goes to 6. So every x goes to 1y, but this y does not have an x that corresponds to it, right? So this 4 is from 2, this 5 is from 1, this 6 is from 3, but this is a lonely 7. So this is a function, but it is not a one-to-one function. You could also list them in like as an ordered pairs, a list of ordered pairs. So you could have 1, 2, 2, 3, 4, 5, 6, 7. So basically, as long as in this really I have to look at just as any of my x's. Do any of my x's repeat themselves? No. So that means it's a function, right? And to be one-to-one, does any of my y's repeat themselves? No. So you're good, right? There's 1x going to 1y, 1x going to 1y, 1x to 1y, 1x to 1y, and then going backwards, 1y to 1x, 1y to 1x, 1y to 1x, 1y to 1x. Another thing, a function, right? Just a regular function, 1, 2, 3, 4. So here's my x's, here's my y's, my domain and my range. We can go 5, 6, 7. 1 to 5, 2 to 6, 3 to 7, 4 to 7. This is a function, right? Every one of these x only has one arrow coming at it, right? And that's fine. It's okay that 3 and 4 both go to 7. It's kind of like a quadratic, right? A quadratic is a function. But because it passes the vertical line test, right? If we draw vertical lines, it only crosses it once. Once, 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 once. The graph only crosses the vertical lines once, so therefore it's a function. So this is a function. But notice right here, this y it came from 2 x's, right? So this is not one-to-one. Oh, did I write one-to-one up here? This one's not one-to-one, sorry. Up here. So this one also is not one-to-one. So in order to be a one-to-one function, you first have to be a function, and then you also have to make sure every single y comes from 1x. So let's go ahead and write the definition. Okay, so here's the definition. In order to be a one-to-one function, each x value has to go to 1 and only 1 y value, and each y value has to correspond to only 1 x value. Okay, so that's why the vertical line test shows you that there's only, for this x value, there's only 1 y value. For this x value, there's 1 y value. For this x value, there's 1 y value. For this x value, there's 1 y value. Okay? But to be one-to-one, like for this example, right, 7 comes from both 3 and 4, just like this x value, say -2, also corresponds to, say 2 right here, a +2. These two values right here, let me do a different color. These two values right here have the same y value, right? It's still a function, but notice that these two y values are the same, right? So their y value is kind of like this one. Their y value is the same, and they come from different numbers, right? -2 and 2 both go to, say, -4. Okay, so I'm kind of making up those numbers a little bit. But we can see in all parabolas that there's always going to be similar y values, right? Because the parabola goes both up to the left and up to the right, or down to the left and down to the right. It's a parabola. Okay, so that means that there's a second test called the horizontal line test. So in order to be one-to-one function, you have to pass both the horizontal and the vertical. Horizontal and vertical line test. So you have to pass both those tests in order to be one-to-one. So this one, all quadratics will not pass, right? Because they all look like a U or an N. So they're all not going to pass the horizontal. So all quadratics are functions, but they're not one-to-one functions. And so let's look at some others. How about this one? How about this function? All right. So we can see that automatically it doesn't pass the vertical line test, so it's not a function. If it's not a function, then it's not a one-to-one function. So these are square roots, right? Y equals square root of x. That's the parent function of this one. So all square roots will not be one-to-one functions. How about just a horizontal line? Well, that's not going to pass the horizontal line test, right? So that's not going to work. How about a vertical line? Well, that's not going to pass, right? Because it doesn't pass the vertical line test. What about just a regular diagonal line? There's a diagonal line. Does that pass? Passes the vertical, passes the horizontal, so all diagonal lines. So almost all linear equations except for vertical and horizontal will pass. So almost all linear equations are going to pass. So that's how you can test. One way to test if it's one-to-one function is, does it pass the vertical and horizontal line test? So here you can look at these functions and you can see, is it one-to-one or is it not one-to-one? So you can do those tests. You could graph these, or you can look at, hey, what type of function is this? Or is it a function? What type of function is this? Or is it a function, right? If it's not a function, if it doesn't pass the vertical line test, then it's not going to be one-to-one function, because in order to be one-to-one, it has to be one-to-one function, has to be a function first. All right, so it has to pass the vertical line test first, and then does it pass the horizontal as well. Another way they can do this, looking at an equation, is by a more formal definition of one-to-one. Okay, so here's a more formal definition of one-to-one. Excuse me. So if A does not equal B, then f of A does not equal f of B. What that means is, if my x's, these are my x's, A and B, if my x's are not the same, then my y's will also not be the same. Okay, so that's a little different because it's using not in there. So if we want to, we could look at kind of a different phrase called the contrapositive. So if this is a true statement, the contrapositive, which would be true, so that's not the second part, then not the first part. So it goes like this. If it is true that f of A equals f of B, so that's not this one, not that, then A will equal B, which is not this. So it has to do with logic and statements and contrapositive statements, how they're actually equal statements to each other. So we can use this. If our y's are the same, if we make our y's the same, then our x's also have to be the same. Okay, so what this means, f of A, what does f of A mean? F of A, if we take this function, f of a would be minus 4a plus 12. And f of b would be minus 4b plus 12, right? You're just plugging in what's inside the parentheses in for your variable, right? And now we're going to set them equal to each other. So I put minus 4a plus 12 equals minus 4b plus 12. And now I solve for see if a does equal b. So I simplify and find out if a equals b. And I do that by subtracting on both sides. Divide both sides by a negative 4. And we get a equals b. So yes, it is 1 to 1. So it is 1 to 1 function. Now, if we look at the second one, it's a little trickier, but it's still the same. So we're going to substitute a and b in for x one at a time and then set them equal to each other. So let's go ahead and do that. Okay, so we set them equal to each other. Now we're going to solve, does a equal b? Okay, so how do we get rid of square roots? We square both sides, so we square both sides. We get 25 minus a squared equals 25 minus b squared. We can subtract 25 from both sides. And we get minus a squared equals minus b squared, so then we can divide by negative or multiply by negative 1. And we get a squared is equal to b squared. How do you get rid of squared? You square root. What's the square root of a squared? What's the square root of b squared? So you might say a equals b, right? So then it is, right? Then it is 1 to 1. But if we look at the graph, isn't this a square root? So square roots look like this, and they're not even functions, right? They fail the vertical line test, so it can't be 1 to 1. Well, why is this true? Why does it say a equals b then? Well, that's because when we square root a number, we have a positive or a negative, right? So that means I could have a positive a here, but a negative b, or a negative a and a positive b, right? So then they would not be the same. So all square roots, all quadratics are not going to be 1 to 1. Okay, so now I'm done with that. Your problems I'll write down and then I'll practice them. So here you go, page 394, I believe, and then numbers 3, 5, 9, and 11, and then I'll start doing those right here. But that's pretty much the end of the video. If you want to do those on your own, you can. If you want to come back and watch those, go ahead. Okay, so here's number 3. You're asked to use the decide whether its function is 1 to 1, so we see if it passes the vertical, which it does. See if it passes the horizontal, which it does, so it's 1 to 1. Okay, number 5 looks something like this. Okay, we do the vertical line test. Passes, so it is a function. Right, so it is a function. But does it pass the horizontal? Nope. Right, it crosses twice, so it's not 1 to 1. It is a function, it's just not a 1 to 1 function. And we see that it's a quadratic, so we could just look and say, oh, it's a quadratic. It's not going to pass. Okay, so here's number 9. You can look at it and say, hey, what type of function is this? Or, I mean, is it a function, but what type of equation is this? Is it linear, quadratic? We can see that it's linear, right? And it's not y equals some number, right? Or x equals some number. Because this is a vertical line, and vertical lines are not 1 to 1, and this one is a horizontal line. So we can see, so those don't pass. Those will never be 1 to 1. They are functions, but they're not 1 to 1. Or I guess not all of them are functions, because the vertical doesn't pass the vertical line test. Okay, so we can see this is linear, so yes, it's going to be 1 to 1. So we could start, boom, you know it's going to be 1 to 1. So now you could practice setting your f of a equal to f of b, right? Plugging in a in for x, and set an equal, plugging in b in for x, and then solving for a equals b, right? So if you add 8 to both sides, then you're going to divide by 2 on both sides and get a equals b. So yes, it's true. And we already kind of knew that because we knew it's a linear equation. Okay, this is pretty much the same one as your example that I already did. So you know it's a square root function, right? And we know square root functions aren't functions, so they're just relations, so we know this is not going to pass, right? But we could practice anyways. Plugging in a in for x, and set an equal, plugging in b in for x. Oh, don't forget my squared. How to get rid of square root? We square both sides. So square both sides, that gets rid of those square roots. Minus 36 from both sides. You could multiply by -1 on both sides. That will get rid of that negative as well, right? Or I could add an a squared to both sides and add a b squared to both sides. Get rid of a squared. Anytime I take a square root, a fourth root, a sixth root, even any kind of root, even root, I will always get plus or minus. So I get plus or minus a equals plus or minus b. So that's not true necessarily that a equals b, right? And we can know that this is square root, so it's not 1-to-1. Okay, so those are all the problems all done here.